Hello student, I am here to discuss limit test for sulfate. In this class, we mainly focused on principle and procedure of sulfate limit test. Before going to the main content, you should know about sulfate. Sulfate is denoted by SO4 2 minus. It is a polyatomic anion. See this figure, the sulfate anion consists of a central sulfur atom surrounded by 4 equivalent oxygen atoms. Sulfate is soluble in water. There are many compounds available which contain sulfate. For example, magnesium sulfate, aluminum sulfate, ferrous sulfate, etc. Question comes, why it is necessary? So as a pharma student, you know your objective. You have to prepare drug with minimum toxicity. If sulfur present as a impurities in any drug formulation, it will produce toxicity to our body. Therefore, we should know about limit test for sulfate. What is the principle behind this limit test? The limit test for sulfate is based on the reaction between barium chloride and soluble sulfate in the presence of dilute hydrochloric acid or dilute acetic acid. This reaction results formation of barium sulfate precipitate, which is not soluble. That means it is sparingly soluble in water. Therefore, it will produces a turbidity to this solution. Now we are going to discuss how do you perform this limit test. As all of you know that to perform limit test, you have to prepare two solutions. That means test solutions and standard solution simultaneously. So therefore, you should take two Nestle cylinder. One is for test, another is for standard. First label it. Then in the test Nestle cylinder, you take 10 ml of sample solution as directed in the monograph, and in standard Nestle cylinder you take 1 ml of 0.1089% W/V solution of potassium sulfate and add about 9 ml of distilled water. Then add 2 ml of dilute hydrochloric acid to both the solution, that means test and standard. Then you dilute to 45 ml to both the solution with distilled water. Then you add 5 ml of barium sulfate reagent to both the solution. Then stir immediately with a glass rod and allow to stand for 5 minutes in a dark place. In this process, we add barium sulfate reagent to the sample solution and standard solution. Is it? So, both this solution contains soluble sulfate and this barium sulfate reagent contains barium chloride. Therefore, this soluble sulfate react with barium chloride and it will form barium sulfate. Barium sulfate is sparingly soluble in water. Therefore, it produces a white turbidity in the solutions. The opalescence or turbidity produced by this solution is depend upon the amount of sulfate present in the sample. That means if the sulfate is more, it will give more turbidity. If it is less, it will give less turbidity. So by comparing the opalescence produced by the sample with opalescence produced by the standard, we can determine the result. If the opalescence produced by the sample is less or equal, then it is pass the limit test. If the opalescence produced by the sample is more than the standard, then it will fail the limit test. So in this topic, what we got? First thing we got, what is the basis of sulfate limit test? The basis of sulfate limit test is reaction between soluble sulfate with barium chloride, which forms a barium sulfate, which is sparingly soluble in water. Therefore, it produces a opalescence. By comparing the opalescence of sample with standard, we can determine whether the sample passes or fail the limit test. That is all about the today's class. Thank you.